Hello students, welcome to today's mathematics session. Our topic is relations and functions. By the end of this class, you'll clearly understand how elements of two sets are connected and how a function is a special type of relation. Let's start with the idea of a relation. A relation simply shows the connection between two sets. Example, suppose set A has the numbers 1, 2, 3 and set B has 4, 5, 6. If we define the relation less than, we can pair them as 1, 4, 2, 5 and 3, 6. That's a relation.
Sir, what makes it a function then?
A function is a special relation in which every element of the domain has exactly one image in the codomain. So one input gives one output, never two outputs for the same input. Let's recall three important words: domain, the set of all input values; codomain, the set that contains all possible outputs; range, the actual outputs we obtain. Example, if f of x is equal to x square and x takes values 1, 2 and 3, then the range is 1, 4 and 9.
Sir, is the range always smaller than the codomain?
Yes, correct. The range is a part or subset of the codomain. Now let's look at some standard functions that appear again and again in mathematics. They are, first, identity function f of x equals x, second, modulus function f of x equals modulus of x, third, greatest integer function f of x equals greatest integer of x, fourth, signum function f of x equals signum of x, fifth, exponential function f of x equals e raised to the power x, sixth, logarithmic function f of x equals log of x, seventh, fractional part function f of x equals x minus greatest integer of x. Let's explore them one by one. In the identity function, every number maps to itself. So f of x is equal to x. Its graph is a straight line passing through the origin at a 45-degree angle. Domain all real numbers, range all real numbers. The modulus function gives the absolute value of x. We write f of x is equal to modulus of x. For example, modulus of 2 is 2 and modulus of minus 2 is also 2. The graph looks like the letter V, opening upward. Domain all real numbers, range 0 to infinity. Next is the greatest integer function, also called the floor function. It gives the largest integer less than or equal to x. For example, for x equal to 2.7, the value is 2. For x equal to minus 2.7, the value is minus 3. The graph looks like a series of horizontal steps, so we call it a step function. The signum function tells us the sign of a number. It gives 1 when x is positive, 0 when x is 0, and minus 1 when x is negative. So we say f of x is equal to signum of x, domain all real numbers, range minus 1, 0, and 1. Now to opposite functions. The exponential function f of x is equal to e raised to the power x. It grows very rapidly as x increases. Domain all real numbers, range greater than 0. The logarithmic function f of x is equal to log of x. It increases slowly and is defined only when x is positive. Its range covers all real numbers. The fractional part function gives the decimal portion of a number. We say f of x is equal to x minus greatest integer of x. For example, when x is 4.7, f of x equals 0.7. Its graph repeats in a sawtooth pattern between 0 and 1. Domain all real numbers, range 0 inclusive to 1 exclusive. Let's quickly revise today's learning. A relation connects two sets. A function is a relation where each input has only one output. We learned the meaning of domain, codomain, and range. We explored 7 standard functions: identity, modulus, greatest integer, signum, exponential, logarithmic, and fractional part, along with their key properties and graphs.
Sir, will we also learn about 1-1 and onto functions?
Yes. In the next part, we'll study 1-1, onto, and bijective functions, plus solve examples and the verticaline test. Until then, revise the graphs carefully and keep practicing. That's all for now. See you in part 2. Jai Hind.